Today I'll be showing you how to build a Morse code translator using Arduino. This program takes Morse code as input and it produces letters that produce words on the LCD display. So the user inputs dits and das. Short button clicks represent dits, long button clicks represent das. This button is connected to the Arduino. These dits and das make up the letters, and if the user pauses in between the letters, it'll make a word. It'll put a space on the LCD display and separate the previous letters from the next letters. The reason for building this was when I was first getting into ham radio operation, I wanted to learn Morse code. I laid out my options on learning Morse code and what I had available to me. I was looking for something free or just low budget, and I wanted it to be engaging so I could learn it quickly. I had three main possible solutions that I came up with. The first one was just memorizing Morse code. That's the old-fashioned way. It's reliable, it's free, but it's really boring, provides no feedback. I'm a programmer, so I thought about doing a software-based solution. It's pretty reliable. It's like the memorization, but it's also pretty boring, just clicking on something. So I also had this other idea, which was pretty engaging, which is an Arduino-based solution. I guess it's pretty realistic, it's cheap, and it was pretty fun to make. The only cons are that it takes money. Although it's relatively cheap, it still costs money. And of course, it takes time to build. Here are the parts I used to build this. First off, of course, you need an Arduino. I use an Arduino Uno. You can just buy them anywhere online. Of course, you need a computer with Arduino software, and you need a cable to connect the Arduino to your computer to download that software. As far as components, you're going to need a breadboard to put all the other components on. You need one push button. I used a push button, but you can use any type of input that you might want to use to input the Morse code. You need one buzzer. I used one 10K resistor hooked up to an LED. You need one LED. You need one LCD display, one 10K potentiometer. It's just a variable resistor, and you need 20 or preferably more male-to-male jumper cables. I broke this project down into 5 main steps. The first 2 have to do with getting the LED to turn on and testing that the signal is being sent to the LED. This confirms that the button is actually working and that we can eventually send button presses to the Arduino. To set this first step up, all I did was plug the button into the LED with a resistor in between them. The button is powered from the 5-volt power source coming from the Arduino that's plugged into the breadboard, and also the ground from the Arduino's power source that's plugged into the breadboard. After we've hooked up the Arduino's 5-volt and ground to the breadboard, we've hooked up the 5-volt and ground to the button, and we've connected the button to the resistor and the resistor to the LED, and the LED to the ground. We can confirm that the LED is turning on by pressing the button. The LED should now light up. Now we add a buzzer to receive audio feedback from the dits and das that we're going to be entering with the button presses. This buzzer just connects to the other side of the button, and the negative connects to the ground of the breadboard. Here I'm connecting the buzzer to the button and also connecting the buzzer's ground to the breadboard's ground. After we've done this, we can test the buzzer to make sure it's making noise. Then we can move on to connecting the LCD display. Connecting the LCD display can be a little bit complex, so I'm going to go through the pinout and what I did to hook it up to the Arduino. As you can see here, the LCD display I'm using is made up of 16 pins. I have a diagram on the screen now that shows what each of the 16 pins represent and what they do. The diagram on the right shows the completed circuit with the buzzer, the button, and the LCD display hooked up. And the picture on the bottom is the first few lines of the code that we're going to write. I'm going to explain what that second line means. It's going to be pretty important to us and where we hook up the pins in the Arduino. So as you can see in the LCD pinout, the first pin in the LCD is VSS ground. that just goes into the negative on the breadboard that comes from the Arduino's ground power source. Second pin, it's the same thing. It just goes into the positive of the breadboard. Now for our third pin, it's going to go into our potentiometer. This potentiometer controls the contrast of the LCD display. So the third pin from the LCD goes into the middle of the potentiometer. The potentiometer has 3 pins. One of them is positive and one of them is negative. Those also have to go into the corresponding spots on the breadboard, the negative and the power. So we currently have 1 through 3 pins hooked up. So now I'm going to move on to pin number 4, which is register select. So now moving down to the code snippet, I included liquidcrystal.h, which is just the liquid crystal Arduino library, and I made an liquid crystal object called LCD, and I passed in the 6 parameters that it requires. So the first parameter we need to pass in to this liquid crystal object is going to be RS, and that's just going to be the location on the Arduino of what pin it is. So I just put 1 because I plugged in pin 4 from the LCD display into pin 1 on the Arduino. So now onto pin 5. That's going to be the read-write pin. If you look at the code, there's no RW parameter because this read-write pin just goes directly to ground on the breadboard. So now we're on pin number 6, the enable pin. So same thing as the pin number 4, which went into 1 on the Arduino. This enable pin, I passed in 2 because I plugged in pin number 6 from the LCD, the enable pin. I plugged it into spot number 2 on the Arduino. As you can see in the code, I did not use 3 because now we skip from pin 6. We've already done 1 through 6. We skip from pin 6 to pin 11, which is data pin number 4. That is D4 in the parameters list, and I passed in 4. That's just the place where I plugged it in on the Arduino, in place number 4. I just matched these with the corresponding data pin 4 into the number in the Arduino. I did the same thing for 5, 6, and 7. So data pin 4, which is pin 11, up to data pin 7, which is pin 14 on the LCD display. Those just go into their corresponding numbers on the Arduino. So data pin 4 goes into place number 4, data pin 5 goes into place number 5, data pin 6 goes into 6, and data pin 7 goes into 7. Last thing we need to do for the LCD display is plug in the LED positive, which is pin 15, and the LED negative, which is pin 16. Those go into the corresponding spots on the breadboard. Now we still need to do one more pin, which is pin number 8 from the Arduino, is the aqua cable that goes connected to the button that's connected to the buzzer. This is what's going to tell us if we're receiving our high or low signal on the Arduino, and it's going to produce the letters on the LCD display. This is the last pin. I plugged in pin number 8 from the Arduino and to the other side of the button, as you can see in my diagram. It's plugged in before the buzzer. Now that we know our button works, because we tested it in step 1 and 2, now your LCD display should be fully connected, at least with the required pins, and you should be able to adjust the contrast with the potentiometer. So now that you know that your LCD display works, we know our button works and our LED works due to testing it in the first 2 steps, and we know our buzzer works. So now we need to tell the Arduino to take these inputs from the button and turn them into letters on the LCD display. We want it to print out on the LCD display. So I'm going to jump straight into the code. Alright, so the first thing we need to do is include the liquid crystal library. Then we need to make a liquid crystal object that I called LCD, and I pass in the parameters of the pin numbers from the Arduino. These pin numbers are the ones that are connected to the LCD display. So I passed in RS. I plugged in RS from the LCD display to pin 1. I plugged in the enable pin from the LCD display to pin 2 on the Arduino, etc. for data pin 4, data pin 5, data pin 6, data pin 7. So then we go down to this int, and this int is going to be the pin number 8 from the Arduino to the LCD display. It's going to be our input pin. So these variables become more apparent as I explain this code. Jumping into the setup function, we're going to initialize our liquid crystal display, and then this is just standard Arduino stuff. We're going to set the data rate to 9600 bits per second. That's not important. And then we're going to set this pin 8 as an input pin. And this is going to be used in this loop that runs continuously as this program runs. So we have this variable, button state, and this is going to hold if the button's being pressed or not being pressed during this loop. This loop just runs continuously as a program runs forever. So if the button's not being pressed right now, it's going to check if the last time the button was pressed was more than half a millisecond. This millis function, I'm sorry, half a second. So this millis function counts milliseconds from the time the program is started until the program stops running. This just runs in the background and it counts every millisecond. So this end press starts off at 0, but we're going to set it to a new millisecond time down here each time the button is pressed. So if the button has been let go for more than half a second, it's going to try to make a letter with whatever's in the buffer, because it should have something in the buffer like this at this point, or just any Morse code. So right here, if the buffer's not empty, so if it has something in the buffer, it's going to try to make Morse code out of it. It's going to call this function right here, return buffer, and this function calls our function right here with the buffer. So if it matches in here, it's going to make a letter. And it's going to print this letter on the LCD. This is just using ASCII wrapping right here. So then to make words, it's going to see if from the time the button was released was more than 1.5 seconds ago. If it is, then it's going to print a space on the LCD. And if the button's being pressed right now, then we need to update the end button time to right now, because right now is the last time the button was pressed. So it's going to call update state, and while the button's high, it's going to keep resetting this end pressed to the current millisecond time. And if the button's been released, then it's going to calculate how long the button has been pressed from the time it began being pressed until the time is let go. And this is going to be our hold time. So if the hold time is more than 500 seconds, so if the button was being pressed, 500, that's just half a second. So if the button was being pressed for less than half a second, it's just going to add a dot to the buffer right here. And if the button is being pressed for longer than half a second, then it's going to interpret that as a DA whenever it's let go, so just a dash. So that's how the buffer gets filled up with these characters. I mean, as far as the code goes, that's about it. It's not too complex, but you just have to make sure your pins are correct and your logic is correct. But the syntax itself isn't too bad. Alright, so that about wraps it up for this project. You should have a working Morse code translator that translates your button presses to words on screen. So I'm going to try to put the code in the description and timestamps in the description also. Thanks for watching.